Okay, optimization problems. There's always 4 steps when you're doing any problem solving in math. Understand the question, come up with a plan, execute the plan, review, and expand if necessary. So with these optimization problems, when you're trying to understand the problem, you have to figure out what sort of optimization are you doing. Are you finding a max or a min? And what variable are you trying to solve for? The y or the x? So usually figuring out what type of optimization we want is easy. So it wants us to find the production level that will maximize profits. So we're looking for a max. Now we got to figure out which variable. So we have a manufacturer makes X items per day, and the profit function is this. It wants us to find the production level. So it doesn't want us to find what is the max profit. So it's not asking us to find the Y. It's asking us to find how many things should I make a day in order to maximize that profit. So in this one, we're looking for our X variable. So we are trying to maximize, and we're looking for the X variable of that max. Okay. So once we know what we're looking for, now we got to figure out how we're going to find that. Well, as soon as we see it max, well, this tells us that I'm looking for a turning point or a stationary point. And the only way to find, using calculus at least, a turning point is you're going to find the derivative of p of x, and you're going to set that equal to 0. Because when a max happens, that's when our graph changes from increasing to decreasing, and our slope at that point, or our derivative, is 0. All right. So now that we have our plan, we're going to execute that plan. So it tells me that I need to find the derivative. Well, finding the derivative of this, I got to bring the 2 down and multiply. So p prime of x is going to equal negative 0.044 x, because we have to subtract 1 from our exponent, plus 11, because the derivative of x is just 1. So now I need to set that equal to 0. So 0 equals negative 0.044 x plus 11. And now we have to solve for that x. So I'm going to subtract 11. Sorry, negative 0.044 x. We're going to divide both sides by negative 0.044. So we're going to go negative 11 divided by negative 0.044. Be careful with the signs. Make sure you keep the signs where they're supposed to be. So negative and negative is going to cancel out and make it a positive. So we're going to x equals 250. So we always want to revise and make sure that we actually answer the question. All right, so I wanted to maximize, and I wanted to look for the x value. Okay, I found the x value. So it says that we should make 250 items. All right. And it wants us to prove that this is a maximum. So if I'm proving that it's a maximum, there's technically 2 ways that we can do it. One is to do a sign diagram and test with our first derivative. So we're going to put our points, so we're going to have 250 here. Then we would put a test point, so let's test 0. Put that into our equation, our derivative. So we're going to have an answer of positive 11, so we're positive here. So that does in fact mean that we're increasing. Hopefully we're decreasing here, but we need to prove it again with another test point. But the only way to have a max is if we first increase, then switch to decreasing. So let's test with 500. So if I put 500 in here, well, negative 0.04, 0.044 times 500, well, that equals negative 22. Negative 22 plus 11 does give us a negative value. So this is proof of a maximum. We can also prove it's a maximum for our math analysis and approaches students using our second derivative. So our second derivative means take the derivative of the derivative. So our derivative was negative 0.044x plus 11. So our second derivative is negative 0.044. Well, this is a constant value and it's a negative. So remember, a negative second derivative tells me that we are concave down. So because our second derivative is less than 0, it is proof that it's a max. Again, this is just for the analysis and approaches students because math applications and interpretation does not have to take the second derivative. So it is proven that 250 items will give us our maximum profits.